All right. Hello. Happy Monday afternoon, evening, wherever you are, or whenever you're watching this in the world. I'm Alexander. Thanks so much for joining all of y'all again. Great to see everybody. And it wasn't just a one-time thing, just showing up last week and calling it a boot camp. So glad y'all are here again for module number two. This week, kind of as I hinted last week, it kind of is where things gets a little bit real. But this is kind of a weird week to be that like real representation of how the boot camp will go. As you may have noticed, there's a lot of content in week two, and that is by design. If you had some familiarity with programming or some programming fundamentals, maybe you zoomed through and clicked through some of the modules. If you didn't, you're spending a little bit more time going through some of the more, I guess, technical context of them. I think in total there's about 26 hands-on notebooks you could have worked your way through, and of course, maybe double that in terms of the videos and recordings. So I wanted to emphasize a few things as you are working your way through Module 2. I know you've already done most of it by now anyway, but I wanted to emphasize that you did not need to go 100% through every single module video and hands-on lab. That'll be a recurring theme throughout the course. The only things graded in a given week are the final assessments, and I'll review some of those questions today, as well as the final capstone. So, especially in week two, where there are so many notebooks and so many videos, I definitely understand if you had to skip through some of them. So, long story short, don't feel like you have to complete every week 100% to be able to go through the quiz, especially if you have some familiarity with the topics. Um, let's see. Big idea for week two is actually working as a data scientist, right? So, what is a computer program? How do we write code? What are the building blocks of computer programming? I got a nice little like flow chart that I'll dig up after this lecture, I guess. But you did a lot of things in Module 2. You're working your way through those fundamental building blocks of computer programming. You're getting hands-on with Python. You're working through syntax. And then finally, we're actually utilized Python in our first data scientist problem, right? Acquiring data from the internet, cleaning it up, and parsing it through to some analysis downstream. So a little bit of that data engineering, data cleaning persona that we discussed last week. You all can still hear me, right? Perfect. My headphones just kind of made a weird noise, but I think we're still connected. So all good. So yeah, a couple big ideas, and then we'll dive into some of the notebooks that I wanted to go over. Don't worry about syntax either. Yeah, I kind of want to emphasize at the end. Memorizing Python syntax is not the way to go. I like to think that computer programming and learning a programming language is a lot like learning a speaking language, right? A new language to speak. It does, you can't just memorize all the conjugations. You can't just memorize all the vocab words. You actually have to live it, speak it, experience it, and repeat it, right? Repetition is such an important part of learning that new language. So, same thing with computer programming. I wanted to give you an exposure to the big ideas of programming and how they relate to data scientist workloads, but you do not need to memorize anything or even a little bit at this point. As we repeat a lot of this work over the next 8, 9 weeks, that repetition will start clicking into place and you'll start learning that language a little bit more fluently. Don't feel like you have to become a specialist this week. Again, we're still talking with broad strokes here. But at the end of this module, you should at least feel more comfortable reading and writing Python code, again, maybe with a lot of help, understanding the basic blocks of computer programming, interacting with data, and understanding how we acquire data besides just downloading CSVs off the internet. Again, all of this work too, we're going to be repeating and iterating on every single week for the next 9 weeks. Every week, we're going to be interacting with data, we're going to be acquiring data, we're going to be cleaning data, and we're going to be writing programs that do various things. I like this line. It's about building your toolkit. Um, as a computer programmer, it is. I've talked about how it's similar to kind of learning a foreign language, but it's also similar to just like solving any type of problem, or maybe even a construction problem, or trying to build something in the backyard. We need to have various tools at our disposal to do specific things. I need to have a jigsaw, a special saw to be able to saw out special shapes. I need to have this type of saw to be able to chop my 2x4. We need to have hammers and nails and screws and screwdrivers. We need to have all these sorts of abilities to solve the complex problem. Computer programming is like that. We have all these fundamental building blocks, which we'll get into here in a second, but we'll have other tools that we have at our disposal. Things like libraries within Python. I think we talked about how some of those are pre-built, like Pandas and NumPy, but then also machine learning libraries that we'll be using downstream, right? So how can we incorporate third-party tools that other people have already done with my own knowledge on how to solve the problem and put all of those pieces together to solve whatever complex problem I'm faced with. A good example of this is like, maybe that's like too basic, but yeah, like determining whether a number is even or odd, right? It's a very common problem that's been done a million times. So there's likely a function or package that already exists to do that for you. So why do I need to recode the solution to this problem when it already exists? So that's kind of what pandas and NumPy and things solve for us. And we'll get into that a little bit later down the line. I guess a more specific example with pandas that's more applicable to data science. Maybe it's like calculating the average of a group of numbers. That's a very common problem, right? Like we need to know the mean of these numbers, but why do I need to write that code? Why do I need to write a function to say add up all the numbers and divide by the number of the length of the list, the number of numbers in the group? That obviously is a very common thing. So why do I need to write that? And the answer is you don't. The mean function exists in both pandas and NumPy. I can just do pandas.mean, NumPy.mean, and I'll be able to utilize those functions. So again, that's the kind of the idea of expanding your toolkit. What do I need to use from scratch on my own, and what can I use third-party pre-existing libraries and functions to help me along the way? Karen has some great resources on just getting more exposure to Python. Like I said, as learning any foreign language, that exposure therapy is usually the best way to do it fast. So just throwing you in and making you live in a foreign country. Same idea with the programming language. You need to be surrounding yourself by kind of videos and hands-on labs and things like that. I love all of these. I use W3 schools. I still use W3 schools all the time. Not only do they have some hands-on tutorials that you can do, but they also have various quizzes that are good practice for our for our assignment assessments as well. So, for example, if I go to Pandas, I can actually see an example of a Pandas quiz. It's not going to be 100% kind of what our assessments are, but I like them. And again, I still use W3 schools when they add new things. And I always pitch them to my boot camps. So thanks, Karen, for including that. And then, yeah, Google has some really great not really blogs, but tutorials and documentations and classes, not just around Python, but they also have a good machine learning one as well. And again, we'll review some of this stuff when we get closer to the topics. But again, it's worth emphasizing that Google's documentation is really good on some of this stuff as well. Let's get into the meat and potatoes here. Oh, here's my recap video. I'm gonna try and post the recap videos at least on Fridays, maybe Thursdays if you're lucky, but probably Fridays. This one was really long, so no worries if you didn't watch it. Usually I'll try and keep them to about 15 minutes. So recapped week one, how to think like a data scientist, and previewed week two with our big ideas and functionality. Try and engage in the discussion forums if you can this week. It's been a little bit sparse in there, but no worries. I know we're all busy and there's a ton of stuff here. All right. All good on logistics, house cleaning. I'm excited to spend less and less on house cleaning stuff every week as we get more used to the format of the course. I think last class was like 30 minutes. So. Oh, friendly reminder for this. Karen's in the chat. So if you have any questions that come up and I'm like nonstop talking, just feel free to drop it. And it can be a logistics thing about the class or anything specific about Python or any of the like stuff that I'm talking about that I didn't give you good context on. So make sure to just participate in the chat if you have questions. Or raise your virtual hand. That's when I see you. And if you really want me to answer your question, that's the best way to get my attention. I have all your faces up on my second monitor. So it's like I'm kind of teaching, content and all you. Anything to add, Karen? And then we'll jump into content here. Cool. All right. Plan is to spend about an hour reviewing some of the week two content, and then the last 10 minutes or so, we can stick around for a Q&A, or maybe I'll do some of the quiz assessments. All right. So, um, I have I'll update my GitHub with some of my learning notes here in a sec. But these are the big ideas of everything that you should have been able to accomplish in week two. I like to distill this down a little bit more into just this right here. What are the key building blocks of computer programming? And then to actually get started with what we're going to be doing in the next couple weeks, how do we start ingesting data and then start cleaning it up? Again, this was more of a week three preview if you got that far at the end. All right, so let's start with this. What is computer programming? How does it work? And what are the core principles of it? So, obviously, computer programming is the language that we type, or I guess AI agents type sometimes, for a computer to execute, right? It's usually going to be just a set of commands, a set of tasks, and then the computer goes off and runs them as needed. Computer programming has been around for as long as there's been computers. There's a couple of references to this, but obviously, computer programming started as kind of binary code or even punch card codes. If you've never seen Hidden Figures, I definitely recommend watching this movie at some point. It's about a decade old. But it's got the computer programmers of NASA from the 1960s in the United States, and back then, a lot of those computer programmers were women, and they utilized create like punch card computers to be able to write their programs, which actually came from IBM, the first kind of big computers here. So we've gone from using punch cards as a way to write programs to actually being hands-on kind of with our keyboard. And I'll see the next progression from this is actually going to be binary code, or like just writing like very basic commands in a very esoteric language. And then we slowly get more and more to writing English-based computer programming code, which we'll get to here in a sec. Yeah, one last note on the punch card programming. If you ever hear the term, I have a bug in my code, that used to be a very literal saying because that actually came from these punch cards. Bugs would get squished when you put the punch cards kind of into the
Uh,
computer.
uh,
And no, go for it.
earlier, earlier, at least the urban legend, if nothing else, is that it was the Mark II computer at Harvard. It was all relays and stuff. An actual bug got stuck in one of the relays.
Yeah, I also heard kind of in I think they even bring it up in this movie,
In
like
fact,
kind of the
according to the
context of the.
legend, it was the bug was found by none other than Rear Admiral Grace Hopper, who invented the COBOL language, among other things.
There you go. I want to kind of fast forward to the 80s, and then this is a more this is in Stranger Things. I think it was
But I'll
Visual
just
Basic, right?
interject that to show how old I am. I first learned programming on punch cards.
Oh, Basic. There you go.
Fortran on punch cards. A language like BASIC, but on teletype machines.
I think it was season two. So I want to fast forward to yeah, season two of Stranger Things, the big kind of Netflix phenomenon. I was kind of nerding out because it was one of the Sam from Lord of the Rings from the movies. I can't remember his name, but he was actually programming kind of one of the computers within Stranger Things in the lab. And you could see the kind of more esoteric language that we have here. So obviously this is more advanced than punch cards. It's actually using conditionals and loops. Hopefully you see some of these kind of familiar. For I equals zero, like we're doing a for loop here as we're moving around. We'll get to the syntax in Python here in a minute. But again, where I kind of want to get to is if you were writing computer programs in BASIC, which is one of the very first languages on Microsoft's stack, you had to have your own syntax, or this is computer-based syntax. There's nothing really familiar to us about it, neither in terms of reading or writing it. This made it very specialized, right, in learning how to be a computer programmer. And again, this is in the 80s, and BASIC has had a very long evolution. BASIC used to be it is the name of the computing language. So I can find yeah, beginner's all-purpose symbolic instruction code. There you go. That was kind of the first like real like programming language. And then from there, Visual Basic has evolved. My first language was actually Visual Basic, which was a little, again, kind of a still an old school one from the 90s, but I was coding in it still in the late 2000s, early 2010s. And then this kind of eventually got replaced out by C sharp and F sharp. And then there's been other kind of parallel languages evolved outside of the Microsoft ecosystem. For example, you may have heard of C or C++, which are their own kind of language and compilers for programming. And this is actually the track that Python went. So basic, Visual Basic, C sharp, F sharp, those are all known as compiled languages. You need to write them, then you compile them as one big block of code, and you submit it to your computer to execute. As we kind of get into Python, we actually move away from that idea of compiled languages. C and C++, I'm pretty sure are still both compiled, but Python is not. With Python, we can execute line by line how we go, and a lot of things are inferred by the computer. So the evolution where I want to get to is that with Python, we've moved into a syntax that's more English based, right? We are actually writing words that if we read them aloud, they actually kind of make sense as if we were telling the computer the commands to do. So we've gone from punch cards to more esoteric, specialized languages like BASIC. And then as we kind of moved and evolved over the last kind of 30 years of programming, we've gotten more descriptive with how to write that code. So even though the syntax for Python is still kind of a mess, just know that it could be a whole lot worse depending on how far you go back. And then the other reason why I bring up all those other languages is because these building blocks of computer programming are going to exist outside of Python, right? They supersede Python and go all the way back to the very first programming languages, including those of BASIC. So I like to think if you're thinking along these lines of these are the main tools in my tool belt, you'll actually be able to write code in any language, Rust, Java, C++, even C sharp, right? All right, so what are these four basic building blocks of computer programming? If you take nothing out of this class except for this, then I am happy. There are four main building blocks of computer programming. Number one, your nouns, aka variables and data structures. These are the representations of your objects that are going to be doing work or have work done to them. How do I want to transform this number? How do I want to interact with this list of numbers or this group of numbers? Again, variables are going to be more of your single representation of an object, while a data structure is a representation of a group of objects. And we'll get into the various data structures later. But in the course of your readings, you should have read about tuples, lists, sets, and dictionaries. Those are all encompassed within data structure. They are all ways to represent groups of objects. So these are our nouns, individual slash groups of objects, usually numbers that we want to interact with. Then we actually get into the program itself. How do we interact? What are the verbs that we're going to be doing? The verbs of computer programming typically fall into two sections. Conditionals, which is going to be your control flow, is how you also may hear about it. If something is true, do that. Otherwise, else, do something else. So we have branching, we have various actions, we have a control flow of the work being done to our objects. And then the other big verb that we do to our programs is looping. This is the number of times that we want to do something. You'll end up interacting with two types of loops in this class. We're mostly going to deal with for loops. You don't need to know the specifics, but at a high level idea, a for loop will iterate for a specific number of times. I want to do something 10 times. I want to go through this list and do something 5 times. I have a set specific number of times I want to do an action. A while loop connects loops to conditionals. While something is true, then do the action. AKA, we run until a condition occurs. A typical thing for this is I like to frame this all like actually yeah let's do this. So my metaphor for all of these like building and programming we talked about toolkits and building a house earlier. The other maybe easier one is let's write a computer program to make a sandwich, to make a peanut butter and jelly Marmite sandwich. So to do this, right, we need our nouns. The nouns that we're going to be interacting with are going to be bread, jam, peanut butter. Maybe that's about it. Maybe a knife is what we need to help facilitate those actions. So those are my nouns. Then we can have a conditional. If there is no jam on the bread, put some jam on it, right? And then else, don't put any more jam on it. And then we can tie this into a loop. If I want to do a for loop, I can say, with my knife, I want to 10 times dip it into the peanut butter and spread it on the toast. So I want to make 10 spreads of peanut butter. That would be a for loop. Or if I wanted a while loop, this would be something like while the amount of peanut butter is less than 2 tablespoons, keep spreading it or keep scooping it onto my plate. So we have a condition that needs to be met. Until I've met half a tablespoon, I feel like that's not a lot of peanut butter. 2 tablespoons of peanut butter, then we're going to keep digging it into the bread. So those are the big ones. And then finally, functions and classes allow us to reuse code, right? So there's going to be code reusability. How do we make sure we can bundle up and reuse across different problems the same logic, the same computer programs that we've already written? You'll also hear functions and classes related to the concept of dry and programming. We're going to be full of acronyms in this class. So dry is a first one to know. Dry stands for don't repeat yourself, right? If you have to use the same logic over and over again, you should probably either be using a loop, right? 10 times, do this specific block of logic, or you should be bundling that logic up into a function so we can reference it in multiple places across my code block. So yeah, this also really helps with things like debugging, finding the bugs in your code. If I know is something wrong with spreading peanut butter, I don't have to look across all my recipes that involve spreading peanut butter. I can just go straight to the one function that defines how a knife spreads the peanut butter and debug the problem there. And then hopefully that'll just trickle down to all the recipes that reference that function. So reusability and I guess don't repeat yourself with that code. I don't care as much about functions and classes this week, just because you need to be able to write code before you make it reusable. And then finally, intro to pulling data from APIs. We'll review this pretty quick at the end, but this is something we're going to iterate on over the next few weeks. How do we interact with data besides me just giving it to you or you just finding a CSV on the side of the street and loading it into your computer? APIs is a common way for data vendors to supply data to consumers, including us. Let's get into the code. Let's hope I remember which one's which. We're gonna start. Oh yeah. Also, let's hope that the IBM Cloud gods are liking us today. I want to start with pipes, I guess. Let's do it. So I'm gonna start with 214, I think is the lab I want to start with. And I don't expect you to necessarily follow along with every lab we're gonna do here. These will start pretty quick, and then I'll spend more time on 211, which is kind of the capstone keynote project of the week here. All right, so I like this notebook because it introduces us to the concept of like individual variables or individual kind of variable objects. You can all see my screen, right? Yep, here we go. So this notebook should be up and working, and we should be able to run kind of this first cell. Awesome. All right, so when we define a variable, not a data structure necessarily, but an individual variable, that individual variable has a representation of its object defined by a type. So this number is going to be an integer, or this number is going to be a decimal number. I only have the two options there. Or maybe it's not a number at all, and it's going to be text, and it's going to be a string. In most languages that I talked about earlier, Visual Basic, C Sharp, even to an extent C and Java, you need to declare that data type at runtime. So again, remember when it gets like compiled, we need to know what the language looks like or what the variable looks like. Let me pull up a variable declaration in C sharp here. So there we go. Let me see if I can find like an example of it. So in C sharp, if we're writing C sharp, I will have to say this variable, my number, is an integer, and I'm setting it the value of 100. The variable name is going to be a string type and is going to have the value of John. And then same thing for this true, false, or Boolean value. Python is not like that though. Python is great. Again, we've kind of moved up a level in how to computer program. Instead, the computer just automatically figures out what data type it is. And almost most of the time, I'll say most of the time, it's actually really good at it. So there's sometimes when we get into data structures and things that the computer's interpolation of the variable can be wrong. And in that case, you do have to do your own explicit declaration or casting, but those are more, I guess, niche problems. So let's double check that this is an integer. If I make a new cell, I can actually type 11 and it'll tell me that it is a integer. Same thing with a decimal number. A decimal number goes by many names in computer programming. In Python, it's going to be called a float. But if you have SQL experience, you may remember that there's multiple types of decimals and you can actually specify the length of those decimals and how specific you want the number of digits to be. In Python, it doesn't really matter. We'll just call all decimals floats. Note that in some languages, you'll hear double as another name for a decimal number, double, or float or decimal. So there's at least three names you'll have for a very similar data type. If you don't have a number, you most likely have a string. The string is going to be any value that's comprised of text. And then the last one would be Boolean. I'll just add this as a quick, oh, maybe it's further down. Oh, that's got casting. That's what I want to go over. Oh yeah, Boolean's down here. So the last one's going to be Boolean, which is only going to have one of two values, true or false. And Python allows you to also flip between 1 and 0 and true and false pretty easily as well. So again, those are going to be your main variable types: integer, float, string, and Boolean. You'll also have in Python a date data type as well, or date time, which is nice. If you ever want to add like minutes to an hour, since that's all in like what base 12, like adding 60 minutes and things, it can be kind of funky to do that. So having this date data type in Python allows you to add minutes, seconds, hours to other time objects really easily, which is nice. Cool. So besides those basic data types, I want to quickly also talk about converting and changing data types. So to do this, we need to use casting is the verb of what it's called. And here is an example. I'm going to take the integer number 2 and I'm going to convert it to a decimal number. And so by adding this float around it, we are hard casting, converting this integer to a decimal number, and we can confirm it is a decimal number. Same thing from going from decimal to integer. If I do an int, this will convert it to just 1, just taking the first there. Note that it's probably recommended to round the decimal before casting to an integer. This is probably the most common usage. Let's say that you have a CSV and Python mistakenly read everything as a string. We need to convert those columns into their numeric representations. We typically just explicitly cast the string to whatever value it needs to be. So in this case, we have the value of 1 as a string. Notice the quotes. And to turn it into an integer, we wrap it around the int function. You'll notice that as you start writing the code, you get some visual cues as to what the variable is going to look like. Typically, if it's green, it's going to be numeric, and if it's red, it's going to be a text object. Note that if I try to convert something that is obviously not the correct data type into a number, this will throw an error. So if you ever get a value error, it means the value of your data type is typically incorrect. Cool. Last thing I wanted to show on Booleans. Oh yeah, Boolean 1 to 0 is how you get the true false. And then there's some also interesting things where you can be like true is equal to 1, and that comes back as true. So again, with Boolean values, where we see if something's true or false, 1 and true are the same value, basically. Does it confuse you even more? You don't need to know it. This is bonus knowledge. But if you want to code in JavaScript, let me get rid of all these errors on my page. We're just go to console. So JavaScript's really funny because if I do that same command, true equals 1, this comes back as false or, oh my God, true all lowercase. Freaking JavaScript. Also, JavaScript is case sensitive while Python is not. So, oh, it does come back.
Java
If
and
I do triple
JavaScript,
equals.
true is lowercase t.
Yeah. So in this programming language, we have to use three equal signs, and this comes back as false. So the reason why I just like showing this as just an extra bit of knowledge is because in JavaScript, in this specific programming language, which you don't need to know, but in this specific language, it actually checks for both data type and value. So in this case, true and one both have the same value of being true, but they have different data types. True is a Boolean, while one is an integer. So in this specific language, if I try to use three equal signs, which is basically like strict comparison, it'll say, yep, they have the same value, but they have different data types. So it comes back as false.
Yeah, I think
And again,
also
note,
one, two equals uh, a single quote, one single quote, like a string. One and a string of one, it will be, if two equals will be equal, but if three
because
are
the
the,
values are the same. Yeah,
yeah,
but the data types are not. But no, that Python doesn't do this. Python, super chill
fortunately.
language. Yeah, yeah, maybe to some it would be a
There are some
disservice. But yeah,
strange things in JavaScript, and you have to consider that the person who wrote it originally wrote it in a week.
yeah. Anyway, back to Python. Again, I like showing this with Python because again, I want to emphasize this week that these ideas about data types and variables, data structures, conditionals, loops, they transcend Python. And then B, every language has their own unique quirks, but if you understand the 10,000-foot big ideas, you can fumble your way through most languages and problems. So again, it also goes back to my personal view of never memorize syntax because that doesn't help you across multiple languages, right? Every language has their own kind of syntax. Like for example, like Python and JavaScript, maybe there's some similarities, but the dialects are going to be pretty different, right? So again, this is more about that exposure to the problem itself and then fumbling your way through the exact syntax. But if you remember at a high level that I have data types, which are separate from the data values, and those data types are going to impact how certain actions are done to it, then you'll be able to kind of move your way through kind of most programs. Cool. So that's the introduction to data types, and I want to now go over data structures. So you had a lot of labs on data structures. I'm going to start with just lists. I'm only going to hit on two data structures here. So that should be 242. So with data structures, as we talked about, it's a way to group nouns, it's a way to group our objects. So there's different ways of defining these groups. The most common one is going to be a list. So a list is exactly what it sounds like. It's just like a shopping list is a group of strings. It's a group of things I need to go out and buy. A list of numbers would be something like, I don't know, 1 through 12 as the months or 1 through 30 for days of the week. We have a list of numbers. In Python, you can also have a list of various data types, which is fun. You can have some strings, some numbers, some floats, some date times in there. Note that not every language allows you to do that. For example, if you code in Excel and you use macros, fun fact, those macros coding in Microsoft Excel is based off of Visual Basic and C Sharp and the basic language that Sam from Stranger Things was coding in all that long time ago. But in an Excel program, you have to declare a list as only having one data type. This is going to be a list of strings. This is going to be a list of numbers. But again, Python, big idea, super chill language. It can let you do whatever you want, however you want to do it, and typically a pretty readable syntax. All the other data structures we'll talk about are going to be basing themselves off of lists. All right, so just to my notebook should be ready to go. Just as an example of this, here is a list. It contains a string, it contains a float, and it contains an integer. And here's what it looks like. And if we look at the type of my variable, it is a list. Wow. Fun fact with Python, we start counting at 0. So the very first item is going to occur at position, aka index 0. 0, 1, 2. Fun fact, not every language starts at 0. So if you memorize it and you run into a language that starts at 1, which, funnily enough, is R, our language, which is a statistical language we talked about in the onboarding, it actually starts counting at 1. There is no index 0 in R, which is kind of funky. But again, more just examples of how all languages are the same, but also slightly different in their nuance. As we've talked about here, if you go back negative, if you do the reading, it kind of goes back to the like in a circle. So if I wanted to get the last item in the list, this can either be bracket 2 or bracket -1. It's kind of like those old school arcade games where you shoot off to the left and you wrap around and come back on the right. Same thing with the list. If I go -1, I go off bound to the left, wrap around, and come back on the right. So -1 is going to be 1992. Same thing with -3. We wrap around, -1, -2, -3. We end up back at the bodyguard. Let's see. I think that's most of the things I care about with lists. The actions you can do with lists, there's some interesting ones, but again, I don't know how like, exactly how relevant they are to some of our programs. But you can add things to the end of a list. You can, uh, yeah, with pop, append versus extend. Append is how you add multiple items. Extend, append allows you to add. Oh my gosh. Yeah, I thought append adds one element and extend adds all of them. Yeah, okay. Yeah, so this is what this is doing. With the l.extend here, we're taking the contents of the list and adding those to this list. So we have a list of 4 items. But with append, what it's done here is with append, you only add one item, but it adds this whole list as its own object. So this is called a nested object. We have a list inside of a list, which is kind of crazy. This is where we get very, I guess, Inception. You don't have to worry about nested content too much yet. But when we start talking about things like data frames, you can kind of think of those as nested data structures. I have the entire data frame itself, and within that data frame, I have all my rows, which is kind of the nested list of my rows. I also have all of my columns, which is kind of like another nested data structure within this idea of a data frame. But we'll get into that when we get into dictionaries here in a moment. One more second, James, and then I'll pass it off to you. I don't have too much on the specific actions of lists. I think don't matter as much as the idea of how to group objects together. Yeah, James, do you have a question or anything?
Oh, no, I just wanted to mention that I think you'll bring it up later on when we're looking at some of the other data structures, when we look at slicing. When you do slicing, yeah, I got a bit confused with the elements that you have to use or the indexes and things. But
Yep,
I'm sure
definitely.
when we get there, we'll go through it because there's a difference when you just want to return one element, and then when you want to return, when you want to do slicing, you have to add the last element you must add um, the last element is you have to add a number to
Yeah,
to the element, and that's very confusing to me. So yeah, but I'm sure we'll get to that one.
actually, I think that's a great call out. So yeah, let's discuss how to extract and interact with lists as a data structure. So I'm just going to do these hands-on items, just a short quiz here. So first, let's create a list. I'm going to call this one a list. And with a list, we always use hard brackets. That's how we differentiate the data structures between each other. Dictionaries will use squiggly brackets, and tuples will use parentheses, for example. With our list, as we've done inside of our brackets, we're going to include an integer, 1, the word hello. Notice that if I did not include the quotes around my string hello here, this will actually throw an error and say, what is this? If you do not include the strings, Python assumes it's a variable name, i.e. our representation of the underlying object. So we need to wrap it in strings, so Python knows it is a string data type. We have another nested list inside of here, and then we also have a Boolean called true. So in total, if we check the data type of this, I'm going to use the print command to do that. This should come back as a list. And then if I check the length of the list, it should come back with 4 items. 1, 2, 3, 4. Remember when we have a nested object, the entire object itself counts as 1 element. So we have 4 items inside of this list. Now we can start interacting with slicing and dicing and extracting elements from it. First, it wants us to find the value start at index 1. Remember, with Python, we start counting at 0, 0, 1, 2, 3. So before I even write code or write my program, I should have like an expectation of what my code should do. I know in this case, my big idea is that the code should return the word hello. So we can actually do some trial and error. Let's start by doing bracket 0, and this actually returns the integer 1, not what we want. So let's use item 1, and we get back the word hello. And again, if I check the type of this, it should come back as that string within the list. Next, what it wants us to do is to retrieve the items, the elements, the objects stored at index 1, 2, and 3. This is where we get into slicing. Slicing is also known as subsetting. I want to retrieve a subset of the list that contains only elements within that list. So that's what we'll do in this case. I want to return a subset of my big list that only contains 3 items. Hello, 1, 2, 3, and true. So to do that, we may just kind of should write this code, and this is, I think, where it's very easy to get tripped up. I want to start at item 1, end at item 3, and see what I get back. And I should get back items 1, 2, and 3. Except, uh-oh, what happened here? If I look at this, my response only returned 2 items, and I wanted it to return 3. And this is the problem with slicing. And again, where like the syntax of everything gets really annoying. Most of the time, I have to qualify everything with syntax as most of the time. Most of the time, the second number is going to be exclusive. It's not inclusive. I want all elements of this list starting at 1 and going up to, but not including index 3. And even when we get into pandas and we're subsetting and indexing things with pandas, that logic will hold. I will have to call out somewhere where that may be exclusive or that may be inclusive, but currently the second number is exclusive. I want all items in the list leading up to, but not including 3. So another way to rewrite this would then say if I want items 1, 2, and 3, I want all items starting at 1 leading and up to number 4, index 4, but not including it. And this brings back hello, 1, 2, 3, and true. To me, this is confusing because obviously a list doesn't have an index 4 because there's only 4 items in it. So this would come back and throw an error and say, hey, you can't extract the 5th item when the 5th item doesn't even exist, but it's the required syntax for the list slicing. So this is still confusing to me why they decided to put that in there all these years later. But just note that when we are subsetting and interacting with lists, we are going to 1 minus whatever the last number is. The last number is exclusive. Finally, if you're want a little prof shortcut, if I know I only want all elements after element one, I don't want element one or element zero here in this case, index zero. There are some shortcuts we can do. For example, if I do a list and I just do one bracket, so there is no second number, the last number is implied to be and all others. So this would say take all items starting at index one, going until the end of the list or end of the iterable object. And if I do that, that also brings back these ones. I like doing something like this because this makes more sense to me instead of saying get index exclude index 4, which doesn't exist anyway. So yeah, there's some ways that as programmers we've actually, because Python's an open source language. So if you ever just creep on Python's GitHub, you'll see a lot of people complaining about random things in the in the language itself. So there is a lot of community driven updates to some syntax and things. And we'll get into it when we start talking about pandas in the next couple of weeks. Pandas 2.0 dropped like last year or the year before, and it was great because it really helped how it fixed a lot of common complaints that we all had about pandas. But yeah, great comments about slicing and dicing there. You can also interact with lists by concatenating them, subtracting and popping items out of them, etc. But I think that goes beyond the scope of what I need to show here. Good work. So tuples are a list that cannot be changed. So with a tuple, you cannot add more items to them. You also cannot remove items out of them, and you cannot replace items in them. Tuples aren't used very often, but you need to know they are immutable, with immutable being your vocab word for cannot be changed. Not an Ethereum gaming platform. Unable to be changed. It's an immutable list. And a set is a unique list. Sets are used a little bit more often because let's say I want to do something on all customer IDs. I want to make sure I have a unique set of all my customer IDs. So a tuple is an unchanging list. A set is a unique list. And finally, a dictionary is the other core data structure you need to know. Dictionaries don't exist in every programming language, but when they do, they are super powerful. I love dictionaries. They're the best data structure of all. Why do we like dictionaries so much? Because they rely on this concept of key value pairs. With a list, we always declare where each item is via a numeric index, 0, 1, 2, 3, 4. But with a dictionary, we instead specify a text string key to locate the object or the value. And this works really well. Again, here's an example. We have all my various keys. Key 1 represents the integer 1. Key 2 represents the string 2. We have a list, a tuple, and a... Not sure why I did that as a... But yeah, usually the keys are always going to be strings. And we can access their items back. The value of key 1 is going to be the integer 1 as we declared up here. This is kind of a funky dictionary. See if we got a better one. I think this one's a better one. So I'm going to jump down into this store one because I think this is a good use case for dictionaries. So with a dictionary, we're able to hold key value pairs where the value is located by looking up its key name. So in this case, I'm going to have a dictionary. And let's take a look at my dictionary. So here's my dictionary. And again, what I love about it is that I have consistent key names here. My product number is called mobile phone. My quantity is 5. My price is 2000. And my release year is 2020. Guess what we're building here? Let me do a second one. I'm going to create a second dictionary. Oh my God, it didn't create a second dictionary. It just added it to the main one. I guess that's fine. But where we could have gone here is if we looked at my second item, which is going to be a laptop with a quantity 10, a price of 50,000, and a release year of 2023. Those are the same product keys here. So now let's think about how we can relate this to something like a CSV, right? Or a structured data frame with columns and rows. Let me just look at like a CSV, like just image of what a CSV will look like. Great. What if we could represent the column names as keys, and then each row would have values in a dictionary? So let's say we have one dictionary. We can call that dictionary A1, or not A1, just row one. Just pretend that says row one. In this dictionary, I have key ID, value 100. Key first name, value Blinny. Key last name, Lindemann, etc., etc. We now have row one represented by the data structure of a dictionary. We could do that for row two. Row two, we have a new dictionary with the same keys of ID, first name, last name, but now new values. 101, Morgan, and Ophelia as the last name. What if we put those dictionaries into a list? So I have a list of dictionaries where the first dictionary represents row one and the second dictionary represents row two. Now we can extend that for all the rows in my CSV. We have a list of dictionaries representing each unique row, and now we can interact with them via programming. I want row 5. I'm going to grab index 4 from my list. I want the first name. I'm going to grab the key first name from my dictionary, and I'm going to should return the value Dulcinea. That's kind of what we're going to be building here as we get into this idea of a data frame. I want to use lists and dictionaries as my founding data structures to represent an underlying structured data set. Again, don't worry, this will click when we start doing this a little bit more here. When we get into, actually, I'll do it now. Why not? I am going to just do this again. Well, probably not. I don't have time. We'll do this in the data frame section. Or actually, I'll just do it here at the bottom. Why not? So let's say my first dictionary one is going to be a dictionary of ID, and let's do 1, 2, 3, and then first name, let's do um, Nicholas. And then in my second dictionary, I'm going to have, let's do ID of 1, 2, 4, and then a first name of Brian. So right now I have two dictionaries. We can put them in a list called rows. I forgot my brackets. And now if I look at this, you're going to see that it kind of looks like that CSV of what I'm talking about. My columns are going to be ID and first name. In row one and A1, I have the value 1, 2, 3. And in A2, the value would be Nicholas. Same thing for B1 and B2. And then what we're going to get to with pandas, live coding as PD. We then should be able to represent, hopefully that works, of my rows. And now we can see what I'm talking about as, hey, that looks like a CSV now or an Excel spreadsheet. We have my columns and my rows. So as we start getting into the idea of data frames, note that when we get into these abstractions, they are going to be representative of these core underlying data structures and principles that transcend outside of Python. So yeah, this comes back to like why Python for data science and using your tools. I don't need to write from scratch a library to be able to represent CSVs as root core programming objects because that's already been done for us with pandas. Yay. So you never have to worry about some of that kind of minutia ever again. But I want you to understand that when we start using third-party tools like pandas, they are still based on the same core underlying principles, including variables, data structures, etc., as what we've kind of discussed here in week 2. Not too bad. Awesome. Data structures and variables and data types get, again, you need a kind of a lot of, you need a lot of exposure to them here. But it's also good to know that the things we're doing isn't necessarily how we'll be doing them in week 3, 4, 5. Again, last kind of big idea here. Python has its own specific syntax versus like other programming languages. So the purpose of a lot of these notebooks are to introduce you to the wider programming concept, but not necessarily how we'll do with things in the real world in Python. For example, I would never manually type out and define dictionaries for every row of a spreadsheet. Let's say I have a spreadsheet, I was like not even 1,000 rows, maybe even if it's just 500. I am not going to sit here and manually type in all the unique dictionaries, representations of each row, right? Instead, I would just use pandas and just read it into a data frame and skip that step. I don't need to define it as a list of dictionaries, but we'll just skip over that. But hopefully, when you start thinking about APIs now, and again, I'm just gonna, I have like, so I can find the stats API. I don't even know which one I want. I want the, I don't want that one. I want the, this has been a while since I've done one. Oh man, that's what I want. Let's just grab conferences. Why not? So here's a random data vendor. Not really. This is like a real baseball data vendor. But maybe you care about like ESPN or something. If I'm looking at this, right? This is an API, which we'll get to. Look what it's coming back as. You should be able to read this now in terms of your data nouns. Let's look at the root data structure. What data structure is this? It's using squiggly brackets and it's using key value pairs. It's a dictionary. Within this dictionary, we have more nouns. This is going to be a string because it's in quotes. This is going to be an integer. This is going to be a Boolean. And as we start looking at it, within this dictionary, I have a list called conferences that is in itself a list of dictionaries. So now we kind of get to our structured CSV type. My first conference, my first row, is going to have the ID of 301, is going to have no wild card, and it's going to be called American Conference or whatever it is. So this is, I think this is in AAA actually. I don't know why we're in AAA, but maybe we'll do like the higher level like sports. In this case, same idea. We have a dictionary that's returning a list. And within this list, we have all of our individual rows. And this actually is much better because this doesn't have any nested content. Row one is going to be Major League Baseball with these column names, ID, code, link, name, abbreviation. Row two is going to be AAA with these column names. Row three is going to be this guy right here. And now I can quickly say I have 19 rows in my structured data frame. But again, this is why everyone loves Python for dealing with data because APIs, this is not Python, right? This is an API which someone somewhere, a data vendor, in this case, it's actually going to be real MLB baseball. They have a server somewhere in New York that's running this application that's exposing data to consumers. This is not in Python or anything, but with Python, I can quickly understand that this is going to be lists, dictionaries, structured informations with specific data types, including integers, strings, and booleans. And I can easily represent this as a data frame. And then as you'll see, once we have a data frame, we can do statistics and analytics in a really easy way using built-in functions within Pandas. But we have to at least know where to start in terms of programming. And then yeah, back in the day when I was writing software in like C Sharp and Visual Basic, I did have to declare all my individual data types. Baseball ID is an integer and it's going to be whatever this value is. The baseball name is going to be a string and be whatever this value is. But luckily in Python and Pandas, we infer all of that now, which is nice. Also, this is a real public API, so you can definitely hit it from your own computer. Cool. I have a couple more things I want to go over, so we'll see how fast we'll fly. The other parts to kind of writing these programs, as we've talked about, not just spending all this time on nouns, data structures, and objects, but also going to be on the implementation of them. So they only did two notebooks on this, so hopefully we can move somewhat fast. I'm not going to do every part of those notebooks, but let me grab the first one. Uh, 3261. Boom. So now that we have a strong understanding of nouns, objects, and variables and data structures, let's talk about how we can start interacting with them. And I've learned to let it sit for a second until that circle goes empty. Otherwise, it gets mad at you. But let's take a quick look at some of these things. With conditionals, we've talked about how this is a control flow. Do action A if something is true, otherwise do action B. And the way to do a conditional check to see if something is true, we utilize these operations. Are something equal? Are they not equal? Are they less than, greater than, or less than equal, or greater than equal? So this is where things get confusing on the syntax. One equal sign represents assignment. I am assigning the value of 5 to the variable A. Double equals means condition, control check. Does the value of A really equal the value of 6? And that answer should be false, as the value of A, which is 5, does not equal 6. So one equal sign is assignment, two equal sign is conditional check. All of your other ones work as expected. 6 is greater than 5, so let's do some mental kind of values here. This should come back as true. And even for simple programs like this, this is like not the first time I've done this. Always have your expectation of what the code should do and then check the output. And this is what most people, mini rant incoming. This is what most people don't do with modern agentic coding agents, right? And this is what I've said about using AI in this class. I don't care if you use AI, definitely use AI to help you out, especially with syntax. But if you don't know what you want your code to do, and AI gives you code, how are you going to know if it's right or not? Or how do you even know how to debug that AI code, right? Have a strong understanding of what you want your code to do and how it should be doing it, and use that to ground you in whatever kind of response the AI gives you. And again, when we talk about like vibe coding now, you open up an AI coding tool and tell it to do something. If you don't give it like expectations or you don't understand what you want it to do, then you just assume it's right and it'll work. And half the time it's emptying your pocketbook on a gambling website or investing in crypto or something when you may not want it to. So again, just be cynical, have that expectation of what should the code do. And it's also a great mental exercise to help you read code as well. So here's a fun one. Let's say I equals 2. Does I greater than 5? This should come back as false. Not equals. And then we can do the same thing with strings. If we do something like greater than or less than, it's going to be looking at, yeah, some weird code. Don't do this. You never need to compare greater than or less than for strings. Typically, if I am using greater than or less than, I'm actually comparing the lengths. I want to know if the length of whatever this code is that greater than the length of, oh my God, fat fingers. And in this case, that should come back as true. Just comparing strings like this is not real. Behind the scenes, it's like pulling ASCII values, which nobody wants or cares about. So make sure to think about using length, right, to represent greater than and equal. But using equality checks is fine. Cool. And then this is the real kind of use case for why using conditionals. With conditionals, we can have multiple types of actions. In this case, if age is greater than 18, we're going to print this command. Otherwise, we print this command, or this will run regardless. But it should now have 2. But if I set my age to be lower, on my keyboard, Control// is the keyboard shortcut to comment code in and out. Notice in this case, my condition fails to hit, so nothing happens, and I only print move on. And here's the real one. If age is greater than 18, we print you can enter. Otherwise, we say go see Meatloaf, RIP. Otherwise, we print move on. So in this case, because my age is 18, we print this else statement. We fail to meet our condition, so we fall back to the else, and then we also have move on as a finally. Note if I flip this around, I'm 19, my condition succeeds. We go down the first branch, and the second branch, nothing ever happens. So I do this a lot with like maybe in a data frame. If let's just, I guess, sorry for all the baseball examples today. If this was a hit, then do something. If this was an out, then do something else. Right. So we have different ways of doing actions depending on the values of different rows or statements. Cool. Last kind of thing to call out here is going to be loops. And loops are also pretty self-explanatory. I just want to walk through the syntax of how to read a loop. Cool. So with a loop, we talked about how there's two types. A for loop will do something for a specified number of times, or in the case of Python here, we're going to be doing something, an action, for each element in a iterable, in a data structure, in a list. So in this case, for each thing in my list, we're going to do this action. I think this is mostly how Python does for loops. I think if you started looking at some of those more complex for loops, like I'm just going to do in JavaScript again, just so we can see what it looks like W3 schools here at the top. So this is, again, don't worry about this syntax, but with a traditional for loop, we specify the beginning and how many times we want the loop to run. So for 5 times, we're going to do something. This should execute, the text number is 0, 1, 2, 3, 4. So it executes 5 times starting at 0. In Python, this specified number of times you want to use the loop is usually specified by looking at the length or the number of items you want to do actions to. So in this case, we have a list of years. If I wanted to do something for each year, I want something to happen 3 times. But in Python, we don't say something like for x equals 3, uh, do something 3 times, right? In Python, we have to say for the representation of the object we want to loop through, we're always going to be looping through lists or objects or characters or something for whatever it is I want to loop through in the number of items, the list, the object itself that I'm looping through, then do work. So let's actually read this. Again, that's always pretty confusing. I like just starting from 0, or we always start with the first thing, the first item, the first loop. I is going to be 0. Range n, we don't need to worry about too much. That's a dumb way of doing this. I want to do this one down here, but let's do it in its own thing. For I in dates, print I, right? So in this case, what we're doing is we're looping through the list itself. So each I is going to represent the individual item. So in this case, we're going to start at 1982, then go to 1980, then go to 1973. This is typically how most for loops will be done in Python. You have something you want to iterate through, and then you just run through it and then do an action. So maybe the action is I want to add 5 or 34 to every single year. Sometimes in Python, you'll see this wonky syntax. This wonky syntax is, I need to break this down because this is doing some funky stuff. So here's the wonky syntax. It basically says, instead of going by the values of each thing in my iterable, let's go by the index, right? So in this case, I know I have 3 items in my list. Now I need to define the indexes of them. That's what range does. Range basically says we're going to start at 0 and we're going to count up to and include the number that you have here. Or I guess exclude, it's going to be excluding the number 3. So if I actually cast this to a list, you'll see that it's defined as 0 and then counting up to and excluding 3, 0, 1, 2. So now this loop should hopefully make a little bit more sense. If I really look at what this loop is doing, we know that range n is actually going to, I guess, compile to this list right here, this list of indexes 0, 1, 2. So that range n is just a shortcut to then read something like this. We're going to start at I equals 0, and our action is to use that index 0, pull the value, and then print out the value. Then we keep iterating. I goes to 1, get the first index out of my list, which is going to be 1980, and print it. Iterate again. I becomes 2. That becomes dates bracket 2, which becomes 1973. And then we print 1973. And again, maybe we wanted to add 34 like we did below. We do the exact same thing. But again, that's why the syntax is a little bit wonky because it introduces this range function as well as this new variable n, which just dictates the length of dates. Also, if you see this in the real world, it'll actually look something like this. I would say for I in range of length of dates. And again, this is just weird syntax. You should know, or no, you'll learn with experience that this function just represents the indexes of this list of dates. Is kind of the idea. And then that prints off the same thing. TLDR though, with for loops, you don't need to know all this stuff. Most of the time when we have a for loop, we're going to be doing what's called in the industry a for each loop, where this is read as iterating for each value in a list, or I'm calling things iterables. An iterable just means like a list, a tuple, a set, something that's like a list, basically. So if we think of most for loops as a for each loop, now it's really easy to read this. For each value, that's I, in my list of dates, get that value, add 34 to it, and print it. And that's going to be usually the way to read these for loops. Sweet. With a while loop, we're not going to be doing many while loops in this class, but with a while loop, the big idea is that we are going to iterate until a condition is met. So in this case, I want to iterate until count breaks this condition. So I need count to be equal to the number 10. So the first thing we do is add 1. If count equals 3, we do nothing. If count equals 8, we break out of the loop. Otherwise, we print count. If I run this, we should get all the way up to 7 because when count is equal to 8, we break the loop. If I just comment this out, though, as well as this one, here is just how a normal while loop runs. We run until my value is equal to 10, and then that breaks the loop because we break the condition. So again, most of the time though, you'll be dealing with for loops. The problem with while loops is they can run forever and nothing will ever, like they'll just keep looping forever. So that's actually why there's a meme out there, which is like while 1 equals 1. Because guess what? That condition is always true. If I print like the letter, I'm gonna blow up my laptop. Let's do it. I'm gonna print the letter A. And so this loop is just running forever. I'm just printing the letter A. Oh my God. Stop, 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 stop. So that loop would have run forever. Oh my God. It's not stopping. Oh my God. Karen. Ah. Oh my God. Stop, stop, stop. Bye, Colonel. Interrupt Colonel. Oh God.
What did
Off.
you do?
It's doing
Control
my
C.
infinite loop.
Really?
Control C would have been a good one. I
Well,
don't know
maybe
why I tried to.
notebook, you might have to just restart the kernel.
I may have just crashed the entire notebook. Hopefully, it didn't
Oh,
kill the whole
good.
kernel for everything. But anyway, that's why while loops are dangerous. And it was actually funny. NASA released like code compliance on Twitter. I don't know what they released. But they tweeted something out about like what mission critical code should look like. And one of it was never use a uh, excuse the language. But this I saw this the other day. Yeah, literally 2 days ago, 4 days ago. It's like here's how mission critical code needs to be written. And it was like you can't use while loops. That's what one of these things is. Every loop must have a provable upper bound. You can't just use
No
while one equals
recursion.
one.
Wow, no
Yeah, no
recursion.
recursion. Yeah, I guess I'll put this in one of our forums. But I thought it was really interesting to read again, just kind of as a nerd who does computer programming stuff.
One thing I don't like, I mean, it's a very common thing in Python to have while true, and you have to make sure you're going to, of course, have a way out of that loop. I never like it very much because it's easy to forget to put the exit clause.
I can also go over 2:30 Eastern here, but I'm gonna wrap this up in the next 5, 10 minutes, and then maybe in that time I'll quickly go over some of the quiz questions. You notice that I didn't spend a ton of time on APIs. I'm gonna do that now. But again, kind of acquiring data and cleaning data, we're gonna do that more in depth next week. Your big idea for week 2 is these fundamental principles of computer science. All right, so this is supposed to be our keynote lab for week 2. You'll notice that it doesn't take me 30 minutes to do this. But we're going to go ahead and kind of walk through kind of what we want to do and actually put these examples to the test. We're going to be using variables, data types, conditionals, loops, and we're also going to be using third-party libraries and other kind of data structures through Pandas and NumPy. All right, so here is our goal. And also, we'll go into web scraping more too in week 3 as well. But we'll kind of go over this now. So here is kind of my goal. We have this URL. This is a real URL, even though it's based on Web Archive, just so we all have a consistent place to scrape from. We're looking at a captured cache of this Wikipedia page of the list of countries by GDP. And if we look at it, we see a table. We love tables. We love a good piece of structured data. So maybe if you were just thinking about how we can do this and you to read this into your Python code to do some data analysis, maybe you need to copy paste it into a spreadsheet and then read that spreadsheet, again, make it that CSV. Maybe if you're curious, you go digging around and seeing if Wikipedia has an API, which it does, but we're not going to be using the Wikipedia API in this case. And so what we want to do is we want to read the root code of this website and use that to extract this information. Again, more bonus knowledge that we'll get into in later weeks. Every website is going to be written in a code called HTML. You don't have to worry about that right now, but HTML is going to be the structure of the website. To get to this page, all that I did was right click in Chrome and then go down to inspect. This is going to be a little bit different depending if you're in Firefox, Opera, or Safari. But if you inspect or use dev tools on a web page, you'll be able to see how it's structured. So for example, this number 17 million, I can actually find it in the HTML. It's right here in the page. So this is where the magic comes in with a computer program. If I can somehow read this HTML representation of the web page, I should be able to highlight where this table begins and extract these different values out of the table and then convert them to a data type. That's kind of the big idea with this lab. And I'm gonna go and here's some I did earlier. And I'll highlight some things that I think are worth talking about here. All right, so the first thing we're going to do when we look at this code is I'm going to use Pandas. Pandas has some great logic to extract structured information from various sources. So all we're going to do here is we're going to read the HTML. We're going to parse out whatever tables we find. And in our specific case, it's going to be table number 4 that we care about. And again, we can prove this. Hopefully, if this runs, magic. And if I go check length of tables, our read HTML function actually found 8 tables on this web page. And we can look at them in order. And you'll see that table 0 looks like this, which doesn't mean anything to us. Neither does table 1. This seems like just a misread header. And then the tables 2, same thing. This is a misread HTML header. But table 3, ooh, that's the good one. That's the good stuff that we were looking for. So again, this is kind of a shortcut here. In the real world, you would have to manually check all the tables and figure out which one it is that you needed. But I just wanted to kind of emphasize that. Then we did a little bit of data cleaning. If we notice that we don't have any column headers here and all of these things are a little bit wonky, we're going to cut out this continent column, only keeping the country, and we're only going to keep the first 10 rows, and we're going to add some column headers to it. And so if I compare tables to my data frame, you'll see that it's my first 10 rows, and we fixed the column names, and we still have those same values. If I look at my df.info, I can also look at the data types, and this should be what's interesting to us. Again, we'll do more of this next week, but I want to start incorporating types here. This column, GDP million, what data type should this be? Integer. What is it actually? A string. So we have some more data cleaning we need to do. We have to tell Python. Again, Python and Pandas is great for most things, but sometimes inferring the data types can be hard. It inferred the wrong data type, so we need to fix that down here. And that's going to be the first thing we're going to do. We're going to convert the data type to an integer and then do some more math on it. So in this case, we're using the same casting idea, but we're casting the entire column or the entire list of values at once. Then we're going to convert it to billions and round it to 2 decimal places and update the column name. And if all goes well, we should end up with, oops, in place equals true, right, Karen? I think that's one of the bugs you found.
What's that?
Nothing. There's a bug in the column rename. Yeah, so in this case, now we've updated the data frame entirely. I had to add this last bit of code in place equals true, or you could have just done df equals df. That was a typo in the syntax. Essentially, we didn't replace the data frame. That's why you have all of these with an equal sign. We're always doing some assignment. I'm replacing this column with this column. I'm replacing this column with this column over here. And in this case, I'm replacing this data frame with this data frame on this side. So if all goes well, and it's already saying that the column doesn't exist because I already changed the column name.
We changed the name.
But yeah, we'll throw that back. And again, all I wanted to show here is that this should be the correct data type. Notice that these should be floats now because we have a decimal. If I check my .info, we do have a float representing the GDP now. Cool. Last thing to do is to shove it into a data frame or to shove it into a CSV. We'll do df.toCSV, the name of this file. I'm going to add in some parameters to make this clean. What do I do here? Show index equals false. There we go. We don't want to write the index, which is going to be these numbers as a column. And I can actually probably show that. If I look at the CSV, notice it has 2 columns, country and GDP. But if I did it without this index equals false, let me look at that other one now. It's going to have a 3rd column with that empty index number.
Right, and then
So
when you reopen it in the Pandas, and you're going to get an unknown one as a column for it.
Yeah, so most of the time when you want to create CSVs, you need to exclude the index. And just to round this out of reading and writing files, you did also use more Pythonic way, which is more like general programming, using the with open technique in prior labs. When we get into pandas and things, we'll see that these third-party libraries, much as pandas abstracts away things like the list and dictionary concept of data structures, it also abstracts away that opening, reading, and closing of files, which is great. But I know that's also one your learning to-do lists here, which you did do, but again, those notebooks are less important as they are less representative of what we'll do in the real world. Yeah, just to wrap things up, look at me right on time. Again, I'll stick around for a few minutes to go over some of the quiz questions and if you have questions here. But big idea for week 2. First, your focus should be on intro to programming concepts, which you don't need to understand 100%, but it's just getting exposed to these ideas. So I want to get exposed to two big parts of this. The first is the nouns. That's going to be your variables, your data types, and data structures. What does it mean to be a variable? What does it mean to be an integer versus a float versus a string, right? And then second, the actions. What do I do to those objects? Of course, I can do various arithmetic, but I need to have some control over the flow of the program, aka conditionals. And I want to be able to not repeat myself by using things like loops to do the same transformation to all items in a group, or to just do the same transformation multiple times, or using functions and classes, which again, we didn't really out of scope for this class, but they're good to know. I definitely recommend reviewing the notebook on that to make sure that we can reuse code across typically other programs, not just a specific one. And finally, to pull it all together, we interacted with a website which we read into a pandas data frame, and we double checked the data types, which we saw were incorrect. We did some casting to fix the data type, as well as other transformations, such as renaming columns, doing arithmetic on this list or this column of integers, and then writing it out to a CSV. There were other bits and pieces of information you were exposed to in Module 2. For example, on the API side, we talked about Beautiful Soup. We'll get into that in a future week, but it's good to be exposed to it now. Again, a lot of big ideas still happening in Module 2. Beautiful Soup, long story short, is a third-party library built for Python that allows interacting with HTML and other markup languages a breeze. For example, we have tags and things here. Let me find this, whatever this value is. This is a table tag, right, with a header and a T body. Pandas kind of ignores a lot of that. But with Beautiful Soup, it allows us to find specific elements in a language like this HTML and pull out specific information. So Beautiful Soup gives us more control on how we extract information from web pages. But we'll get into that in a future week. Finally, you're also exposed to opening and interacting files with the with open technique. This is fine, but especially for dealing with data sets, we're going to be usually using third-party tools like Python or like Pandas. Uh, you're also exposed to NumPy. NumPy is the other kind of language behind Pandas as well. You're introduced to NumPy arrays, which basically is a supercharged list that allows you to do more numeric transformations like matrix algebra. So now, if Pandas is built on the core data types and core data structures of lists and dictionaries, but also has the power of matrix algebra that NumPy provides, all of a sudden this one single library can now do a whole lot for us as analysts, statisticians, and data scientists. All right, that is the official end of class here. I have a few minutes spare, so if you have to hop off, say goodbye in the chat. Thanks for being on and paying attention. I want to review a couple of the week 2 quizzes, and then I'll take any Q&A in the chat. And again, this is all recorded, so feel free to just drop a Q&A in the chat if you want me to cover it and hop off. All right, so the module 2 quiz, again, it's kind of goes over all of these things. And again, remember, this is all open notes, open book. And you can have, I think you have 5 attempts to do this. Oh yeah, I started clicking through it the other day to see how hard it was. Continue the last preview. Why not? So here we go. Like in Python, what can either be a positive or negative number, but does not have a decimal point. So this is talking about a data type that is a number, but no decimal. That is going to be an integer. Given a string, how would I grab index 0? Python starts counting at 0. 0 should be the very first letter. My intuition should say that this should be returning the name E. I don't really know what this find function does, but I know I should be returning the letter E. So let's do number B here. I'm just walking through my own logic of how I would approach this. Which of the following code would generate an output of 0.5? I don't know what this double divide means, but 1 divided by 2 seems like a good bet to return 0.5. Maybe if I wanted to, I could Google this. What is double slash in Python? This should return a floor division. So this is integer division. It always returns an integer. That is not what I want. I want to return a decimal. So I know it's not going to be either of the double slashes, and 1/2 is the answer that we need here. Dictionaries, we know that they're going to be stored as key value pairs. Do not have to be strings. We saw that the stats API that I gave an example of had numbers in it. It can have numerous data types. The keys have to be unique and they don't have to be one data type. So for this one, this is a tough question. I'm going to go through what is not a dictionary. A dictionary is not a collection of strings. A dictionary cannot have duplicate keys, and a dictionary can have more than one type. So all that's left is B here as an answer. But we know a tuple is unchangeable, so it's either going to be B or D. I can't remember if a tuple is ordered or not. I do know it is ordered, but
I
let's say
know.
I'm gonna Google it anyway. Is a tuple ordered? This comes back as yes. Again, if you don't trust the AI overview, do look for the W3 schools. And the very first thing here is it is a ordered and unchangeable list. So I'm validated in saying it is ordered and unchangeable. What's the output of this code? We're reading a condition. The way I would do first equals means assignment, double equals means equality. No, gone does not equal go. So we skip down to the else. We print stop, and then we always print Mike. So this should say stop Mike. Assignment x equals 1. More assignment, but let's read right to left here. X greater than 5. This is false. We now set x equals false. X equals false. This is kind of a weird one because technically 0 could be true here, but we actually have the Boolean value, and the Boolean value is always going to be true and false. So false is the best answer here. Let's have a while loop. So x equals 5, while x does not equal 2, print x, and then subtract 1. So again, let's just read this top to bottom. 5 does not equal 2. So this is already true. So this means we do the loop. We print the number 5, and then we set x to be 4. Let me get my pen out because it's confusing. So maybe if I had a notepad, this would help. So first loop, we print 5 and then x equals 4. Yeah, and you can also just make notes in a little notepad next to you as we go here. So now x is 4. 4 does not equal 2, so this is still correct. So the loop still happens. We then print 4, x equals 3. 3 does not equal true. 2, that is true, so the loop occurs. We print 3, and we set 3 equals 2, or we set x equals 2. We go to the top of my loop. X does equal 2, so the loop breaks and nothing else happens. So we should print 5, 4, 3 is my methodology there, which should be A. I'm not going to go through all 20 of these. I'm bored. How do we run a class? All you know here, this is kind of dumb, but this is a pretty basic one, A and B. So we're going to print x equals A, y equals B. Notice the only thing weird about this is that this is in strings, which means it's going to be part of the final text that's printed out. What's the output of the following lines of code? Enumerate just means to make a list. We're going to loop through it. I is the index, x is the value. We're going to print 0 and then 2 times A, which is going to duplicate the string. So it should be 0, AA, 1, BB, 2, CC. Again, this is a hard one. NumPy arrays. This is matrix algebra. I don't know what this does. So maybe you go to your AI tool of choice and be like, I
Well,
think I actually have it up.
that's where if you, assuming you have Python on your machine,
Oh, that's even better. Yeah, that's
yeah,
a great. Actually, Karen,
just use the
yeah,
shell
don't
and just
cheat like
run it.
me. Yeah, don't cheat like me. That's a great call out, Karen. So what you can do is you can actually go into any of your labs. Just
Yeah.
go to the bottom of the labs and just throw in a couple new cells. Or if you wanted to be really clever, if you right click in your lab, you can actually go to new notebook and you can even call this is a great call out. I'm going to make sure to call this out in my recap. We can name this notebook. I don't know how to name it. Rename notebook. Quiz practice or something. And totally in this notebook, we can import pandas and we can import NumPy. And now we should be able to run all the code in the quiz if it gives us a code snippet. Great call out. So I have no idea what this does. Let's just code it into my notebook and execute it. And it returns the number 0. So the dot product here returns 0, which I think makes sense because I think the matrix algebra is like A times B minus C times D or something. But it returns 0. Great work. How do I perform matrix multiplication? This one's tough. I'm pretty sure it says MP dot dot. That's what we just did in the
Yeah,
last
yeah, that's
question.
it. Yeah, the A
Um,
times B will actually element-wise multiply the two arrays. So that's a
yeah.
different thing than doing the
This is a
matrix multiplication.
this is a fun one. Basically, what's going on here is that we're trying to figure out what out will return. And again, sure, you can just run it and see that it returns 1, 2, but it's also fun to look at how it returns that. So if I just print X, we can see that we have kind of like a CSV. We have 2 rows of information here, 2 rows, 3 columns. So when we do slicing and dicing, whenever you see a comma here, the first one means rows and the second one means columns. So we're going to take rows 0 to 2. So that's going to be row 0 and row 1. So we're excluding row 3, which there isn't one anyway. So we're taking the first 2 rows of column 3, right? Column 0, 1, 2. So the first 2 rows of column 3 is going to be 1 and 2. And that's what's brought back here. So that should be array 1 and 2. Same thing here. I'm not going to bother to explain dot. You're never going to do a dot matrix in your life in this class. So if I just run the code and look at what Z is, it's going to be 2, 2, 2, 2. So we'll just do all the 2's up here. Here's the with open stuff. With open this flat file as read as file 1. We read it and then we print it. This should print all of them. So that should be all of them. Complete the sentence. To plot graphs, we're going to use matplotlib. API comes back as JSON, which is lists and dictionaries, which is lists and dictionaries was not an option, so we'll just do JSON. TD tag within my HTML represents a table data. That's what we are looking for in pandas when we read an HTML table. The response, this is like API stuff. We'll get into this next week. I would use Google for this one. What are the 3 parts of a response message? Headers, blank line, and body. Like, what is not in a response? Headers, blank line, and body sounds weird. Why would we be returning a blank line? Encoding, body, cache,
It's
maybe.
A,
That sounds pretty
A.
techy. Yeah. I'm working
It's
my
A.
way up backwards. Bookmarks, history, security. That won't be in a response. And then start, line, header, and body. That makes a lot more sense to me. We have the start and the body. That's also something in a web page, if you read about that. I think it's encoding and cat. This could be the answer, but I think A is probably going to be the best one here.
That's the
Totally
one I
get it
did
if you
wrong.
mix up A and C. Yeah.
That's the one I did wrong because
And then
I
what's the,
forgot about the status line, so I just went to the HTTP headers, which are the headers in the first line.
yeah, this I like because this is true, but the blank line is not, which is weird.
Oh, no, there is a
So,
blank line between HTTP headers and the body.
oh, really?
There is actually a blank line, yeah.
Interesting. So that's kind of a weird question. I think I
It's a
want you
very
to do A though.
old kind of protocols.
Yep, I have to hop here in about 2 minutes. So the last thing on this one is what's the purpose of this line of code? We talked about with beautiful soup. the beauty of it is that the beautiful, beautiful soup, basically why it's called that, it like dissolves the whole web page into a soup, like alphabet soup, and then it finds what you're looking for. So I'm able to find all of the TR, I guess, markers in this web page. I don't know why that's beautiful, but just go with it. So this is gonna find all of the TR elements, and that should be all of them.
One of the best projects for one of the courses I did at USU recently is we had to write our own HTTP server.
Oh, nice. Look at me being so smart. Yeah, cool. So again, the tricky ones here, my advice would be if it looks like if it gives you Python code, you should be able to run it in one of your lab notebook environments. And there's definitely no harm in with that at all. And you should be able to get the results from there. But don't just think about that, go through and kind of figure out reason why the answer is what it is. And again, these are open notes, so I really don't care if you use AI or other kind of web W3 schools and things like that. Sweet. And then just know that as we get into week 3, we're going to be moving out from this general Python, general programming language way of creating programs and going more Pythonic in terms of third-party libraries, open source libraries, and Python specific syntax work. So yeah, as you can see with week 3, we're going to re-review web scraping, APIs, and I think that's it. So, and like cleaning data. So what we ended on today is where we're going to pick up going into module 3. Your focus for this week being exposed to the fundamentals of computer programming and then slowly being introduced into the main material for next week. Next week, web scraping, APIs, and basic data engineering and data cleaning. Should be kind of fun. Any questions in the chat that are blazing?
No,
Um,
current.
yeah, dictionaries and keys. Dictionary, the keys they do have to be unique. The way that I think about it is that a key represents the location of a value in the list. A dictionary is still kind of like a list. So if in a regular list, if I have index 0, that'll always uniquely point me at the first object in the list. So a key, even though it's a string in a dictionary, also has to uniquely point me to the location of a value. So that's why they all have to be unique. If I have a dictionary with the same key in there multiple times, then when I try to extract that value, the program isn't going to know which is the real value I want to extract, which
They
is
also
why
have
they
to,
need
they
to
also have,
be,
the keys
yeah,
also have to be immutable. So for example, you
yeah,
can't use a list to be a key. You'll get
yeah.
an error that says that it's not hashable. And that's
That's
because
why,
what that does under the hood is it actually hashes that key value to make a table, a hash table.
yeah. Usually keys will always be strings because of that.
Oh, they can be integers. A lot of times they are.
Yeah.
And even tuples can be
Uh,
tuples for various
yeah.
reasons.
Cool. Yeah, beta or NumPy. NumPy does matrix algebra, so that allows you to do advanced statistics and mathematical notations. Again, you don't have to know the scope of that. We're not going to be using matrix algebra ever again after this np dot dot, which is why don't worry about the math. You can if you want, but I recommend just running the code here. Big things I want you to focus on. You should know your data types really, really strongly. Integers, floats, Booleans, and datetimes. You should know your data structures, specifically lists and dictionaries, and how lists and dictionaries relate to JSON, APIs, and data frames in Pandas. And then you should know your main tools for writing programs, including conditionals and for loops, maybe while loops if you care about that so much.
But then if you
Sweet.
move on like me and start writing neural network stuff, and then you'll need to know about a matrix multiplication.
Yeah, that's why we start using pandas to help make machine learning algorithms and equations. Having the NumPy backing of pandas really makes it great to help as a data
Oh
source
yeah.
for those exotic algorithms. All
Well,
right,
also
Ida Hart.
NumPy lets you do a lot of vector operations thus pandas can do a lot of vector operations that are a lot faster.
Yep. All right, I had to hard out a couple minutes ago, but I will kind of wrap it here. I will be checking the forums. If you have questions, you can post in the live session thread. I will have this recording up in the next 24 hours. And Module 3 technically launches on Wednesdays. Try and participate in the discussion forums for week 2 if you can. They don't have to be long answers. And I will see you all this time next week. Thanks, everybody. Thanks, James, Karina, Yoris, for sticking around. I will see you all 7 days.
Thank you. Bye bye.
Thank you,
Thanks
everyone.
all.
Thank you all. Bye.
Bye. Have a good day. Have a good whatever. See ya.